Welcome, developers. I hope you're all doing well. For me, it's been a busy time. I've started on a new job, and that took a bit more time to get settled. But here we are. I'm back, and we'll now continue. Last time we talked about the getting of data for particular SimObjects or particular types of SimObjects. And we're going towards a kind of record and playback that we can make with this. So before we can do that, we first need to go and talk about aircraft and airports. Let's start. If we want to go there, we need a few steps for recording. We need to find out what aircraft we're in and where it is, and we need to record the aircraft's movements. And then, needed for the playback, we need to recreate the aircraft at the correct location and then make it move as recorded. So the first two things, actually, we already dealt with. We know how to get data from the simulator, so that's not a problem. We haven't done anything yet for sending data to the simulator, so we can make it move, but it should be pretty comparable, so that should be easy to do. Now, the thing that we haven't talked about at all yet is how to recreate the aircraft at the correct location. So let's start with that. In the API, we have a call called SimConnect _AI create parked ATC aircraft. A pretty long name, but it specifies all the aspects that are important from the perspective of the simulator. We're going to create an aircraft which will be parked. It is what the simulator calls an AI aircraft, in the sense that it is not controlled by the controllers that you have, your joystick or your yoke or whatever you're using to control your own aircraft. It's going typically to be controlled by some kind of program. And this one is intended to be an aircraft that is going to be controlled through ATC simulated. So when we create the aircraft, we need to specify the title, which is the unique identification of the aircraft type and what it looks like, and a tail number, which is of course important if you're going to fly under ATC control, because ATC is going to use that to call out. So both of these are strings, and we can get them from our current aircraft, and we can set them if we want on the aircraft that we're creating. And then the next thing is we're going to put it on an airport, because it is going to be under ATC control. It's going to be parked under ATC control, so it's going to start at an airport. But all you can specify is the airport ID. The simulator will then use its information on the aircraft about its size and its type and find a fitting parking. It will be random. The aircraft will then wait there until it gets a flight plan. Now, this is not what we're going to use, because we want it to appear at a specific location, but let's finish this with that flight plan bit. So there is first the set aircraft flight plan call, and then the release control call. For the first one, we have to specify the object ID, and we have to assign a flight plan. The aircraft will then start following the plan. On the other hand, if we call release control, we only have to specify the object ID of the aircraft, and the aircraft will then be disassociated from that flight plan, so it will stop. That takes care of that basic situation. Let's move to the next way of creating an aircraft. That is creating an enroute ATC aircraft. This is still an aircraft with a flight plan being controlled by ATC, but now it's not parked at an airport, but instead somewhere along the way. We still need to specify, of course, the title and the tail number, but now also a flight number. The flight number is just an integer. Then we associate the aircraft with the flight plan by passing it, the simulator, the path to the file with the flight plan. The flight plan follows a specific format which is described in the SDK documentation. But now, of course, the next question, we said it is en route. So where along the flight plan is it? And you have to specify that as a double value with a part before the period and a part after the period. The part before the period is the step number within the plan, where 0 is the first step or the departure in the flight plan. Then the part after the point or comma is going to tell how far you are between that point and the next. So if you do a point 0, it will be starting at that step. If it's a point 5, it's halfway, etc. Another thing you can specify is whether it should use touch and goes or do a proper turnaround. The difference is if it has to use touch and goes, then it will just land and immediately speed up again and continue on to the next step of the flight plan, whereas with a proper turnaround, it will go to a parking and shut down and wait there for a while before it continues. This is also not what we can use. Instead, what we're going to use is a non-ATC aircraft. So to create a non-ATC aircraft, we're saying that it's typically something like VFR. So there is not a flight plan associated with it. We have to specify the title, the tail number, and then put it somewhere in the world. For this, SimConnect has a struct called SimConnect data init position for initial position. That, of course, has a latitude, longitude, and altitude, and an orientation, pitch, bank, and heading, because it could also be in the air. You then provide a boolean to specify whether or not it is on the ground. The reason for this is you can specify the latitude and longitude and then say it's on ground, and then altitude will not necessarily make a difference because it will find out from the scenery information what ground level is at that point and then adjust the altitude. So you will not have things like an aircraft which is halfway in the ground or a meter above it. And then you can also specify how fast it is currently moving. So if you want it parked, normally you would use 0, specifying the airspeed in knots. But there are also two special values. First one is airspeed cruise. This is a value that the simulator will take from the flight model for that particular aircraft. And it means that you're saying, I don't know what speed it should be. Just look up what the normal cruising speed for this particular aircraft is. And then because the same struct can also be used to reposition an aircraft, there is an additional magic number, which is airspeed keep. In that case, you're moving the aircraft to a different location and saying just keep the position that it had. Okay, those are the three ways we can create aircraft. So if we want to remove it, then we also have, of course, the call SimConnect AI remove object, where you specify an object ID. This will remove that object from the simulation and you should no longer see it. Then, of course, not everything is an aircraft. So there is a more generic version of the call, which says create simulated object. This still requires a title. The title will refer to the object and be a unique identification of that object. And you then specify the init position. Again, latitude, longitude, altitude, pitch bank heading, is it on ground, and how fast is it moving? Now, this is what you normally do, but of course, the flight simulator is also changing over time. So there are some changes in Microsoft Flight Simulator 2024. The problem was that all aircraft need to have a unique title. Now, you will remember that when you start the simulator and select an aircraft to fly in, you first select the type of the aircraft, and then you select the particular livery of that aircraft. And this is more the case in 2024. So they also made changes to the API. All objects still have a title, but you can now also specify a livery. This means the title is now common across multiple liveries, and it is no longer unique. This hopefully means that, of course, you will get titles that are a bit more specific to the type of the aircraft and the variation. But of course, there will also be some words in there indicating who made it. And then the livery will be a specific version painting for that aircraft or other simulation object. All SimConnect calls that do require a title, and that will usually be referred to as a string zero-terminated parameter called SZTitle. There will now be a second SimConnect call where underscore capital E capital X 1 is added at the end of the name of the function, and you will find there an additional parameter SZLivery. So you can again make a unique specification for a particular, for example, aircraft with a certain livery. But then, of course, the next question is, how am I going to find out which titles, and specifically now for 2024, which liveries do we have? If you go to the previous versions of Microsoft Flight Simulator-based simulators, including Lockheed Prepared, then every aircraft model has a configuration file. This is usually called aircraft.cfg. This configuration file gives a lot of information, and that is often quite useful information, especially if you want to create that using those AI creation calls. So you need to find out where all those files are on disk on your system, then find out all the copies of aircraft.cfg, which is an ini file format file. And if you have multiple liveries, then you might have references to the common base aircraft CFG. Gather all the livery sections, and those sections are usually called fltsim.somenumber, and then from those collect the title entries. For everything up to 2020, this will work. It has always worked, and most tools use that, but it's never been formally supported by any version of the simulator because it's very dependent on the particular version of the simulator and also on the maker of the add-on, because it depends on how much data has been added. For example, some of the aircraft made by third-party add-on providers that come together with Microsoft Flight Simulator have no information about the aircraft type in ICAO code, even though there is a standard designator, a standard field for that in the aircraft CFG. But for Microsoft Flight Simulator 2020 and before, this is the only way we can find out this kind of information. For 2024, we now have a call, SimConnect Enumerate SimObjects and Liveries, for a particular SimObject type, and of course you can use the SimObject type all. It will return a new message type, SimConnect receive enumerate SimObject and livery list. This is an extension of a list type, and it contains extra fields because you have multiple messages. So you get a DW entry number and a DW out of. With the SimObject data by SimObject type, you may remember we also had these fields, but then they were named in all lowercase. Now you see them named in camel case. And the other difference is they used to start at 1 and now they start at 0. So don't look at the name and say, oh, that's the same kind of name, so it will behave the same. But at least we can find out when list is complete. And every single message will now contain an array of structs, and every struct will contain two strings, one the title and one the livery. What if we want to create an aircraft? And let's for the moment just forget about the replaying, that we know exactly where the aircraft needs to start. But we want to create an aircraft on an airport, but we don't want a random parking. We want a specific parking. Well, that data is available as well. We can query airport facilities, but this is a bit weird because the data definitions that you need to use for this are unlike the normal SimObject data definition. Facilities are structured items. And with that, I mean they are items that can have sub-items. And every level has fields. So for example, if you want to query for the parkings, you have to first say add to facilities definition the string open airport. Then you can add the string ICAO, which gets the field with the ICAO identifier of the airport, and then open taxi parking. This will now say that within that airport, we want the sub-objects taxi parking. And for that, we can ask for the type, name, etc. Then when we have specified all the fields, we close the taxi parking and then we close the airport. If you forget that, you will get errors reported. And of course, this looks like we have one parking, but no, what you actually will receive is data first specifying here comes an airport. It will receive a unique ID in the set of answers. And then the next message that comes is here is a taxi parking, and it is a subfield of, and then specifying the ID of the airport. And then you will get another taxi parking, again being a part of the airport. So you will get multiple taxi parking replies for every airport reply. You will not get a close reply. So what you do have is a specific message saying we're done. Here, the type specifies whether it's a parking or a gate, whether it's for general aviation or military or cargo or a dock. There are several different types, and there are even a number of military variations. You have to look into the documentation to find out all those. Then the name and suffix are not strings, they are also numbers. And there is a list what those numbers stand for. So to say it could be a gate, or it could be a parking, or one of all the other variations, but it could also be gate A through gate Z. Those are specific names. And then you can have a number after that. So for example, on one of my favorite airports, Groningen Airport Eelde, there is a gate A1, gate A11 and a gate A12. And of course, it could also be that we have instead an airport where they have a different way of saying it. So it could be one gate A or something like that. There could be a number of combinations that you can create in this way. If you go and browse the particular starting points for a flight, when you choose for a custom flight somewhere on the Earth, you first select the airport, and then the second drop down will show all these gates, all these starting points that you can choose. Next, we have the orientation and heading fields, and orientation has to do with forward or backward. And this is to do with in what direction should the aircraft be pointing when it's parked here. But it also influences where the pushback is going to try and start. Next, we have the radius, which is the circle size in meters of this particular parking. We have two values named bias X and bias Z. Don't ask me why Z, but this is in meters north and meters west. Where on the airport are we? I think it might be east, sorry, bias Z, eastwards. So if it's negative, it's westwards. And bias, the other one, north-south, is of course positive is north and negative is south. There are some computations you need to do to combine that with the latitude longitude of the airport, and then you can get latitude longitude for this particular parking. Last field I've specified here is N airlines, which is a value you can request, and that shows how many airlines use this spot. And yes, that means you can have a list of the airline indicators for this parking to find out which airlines are supposed to be parked here. And this is another thing the flight simulator can use when it tries to find a fitting spot for your aircraft. So why does it have this structure? And that is something that comes to us from the past. It comes from the BGL file format for background graphics library. And why background? Well, the first flight simulator actually always showed you the world through the cockpit windows, so it was for displaying things in the background. The structure of the items returned by this request facility data call directly reflects the structure of those BGL files, and quite often add-ons used to scan these files themselves, because there's some reasons why you would want to do that instead of using that call, because you can do it when the flight simulator is not running. If you go to the fsdeveloper.com site, you can find detailed documentation on these file formats and also how they have changed over the different versions of Flight Simulator. So why go into this and what am I doing with all this? I have been working on some code to do these calls and read the files, because when I worked on CS SimConnect, I also used fsdeveloper.com as information and built parsers for a lot of those simulator files. This gives you much better performance, and as said, you can do it while the simulator is not running. In Microsoft Flight Simulator 2024, a lot have changed, and the reason for those changes specifically for the aircraft and liveries is the so-called modular add-ons. And with that, they mean probably that now the liveries are modules added to the aircraft base. They use a different directory structure, and as we now know, Flight Simulator doesn't download and install all the files immediately, so the files aren't always available. Okay, let's go back to the goal, record and playback. So what we're going to do simply is just record the title, or for 2024, title and livery, and then we'll record the location and movement. We'll recreate the aircraft as a non-ATC AI aircraft that gives us the positioning using the init position record. And there's some interesting stuff here you can do with position versus movement, because of course we want to make sure that when we recreate the aircraft, it moves in the same speed. If we just play it back as fast as we can, it could be that we get something flitting across the airport and through the air at a much higher speed. So we need to carefully keep track of time and use that to maybe interpolate between recorded positions and recreated positions. And there's, of course, another reason why you would want to do something like that. Suppose we have a small server to distribute the data. How do you compensate for network delays? So if you do this right, and it's not that difficult, I think, to do that, you basically can build a multiplayer server quite easily. Okay, wrap up for this lesson. Finding out what aircraft and liveries are installed is, well, let's just say it's somewhat of a mess, although Microsoft Flight Simulator 2024 has some improvements. Finding out what airports are there and where you can park is more doable, because the request data on facilities, or request facilities data, has been around for a bit longer, but it's a lot different from the normal request data on SimObjects, so it takes a getting used to. Creating AI aircraft requires us to at least know for sure the title and the livery of an aircraft, but if we are recording that, that shouldn't be a problem. And if we want to spawn them on a specific parking, then we need to know the airports and the parkings. And we've looked at the calls that you have available for that. And if you master all of this, you can build a record playback, as we're going to do, and even a multiplayer server. So let's end lesson 6 here. I will continue cleaning up the code. I mean, it's not that clean yet that I like it. I've been using some AI to create some translations from C# to C++, and as that goes, it is a mess. Vibe coding gets a lot of press, but I mean, like the guy who originally started that name, vibe coding, you have to do that if you don't care about the quality of the code, because it doesn't look clean. But it is pretty far already. It works, and I'll put it out there. There is a program, MSFS list, already on GitHub. You can take a look. Don't expect it to be too clean yet. So next time we're going to put data or send data to the simulator and put it on the SimObjects, and we're going to do a record playback. As always, I do this for the subs and likes, so if you like this lesson, please leave one of those, and I'll see you in the next one.